On this warm-up, we have 3 lines. We're going to use the 2 blue points to find the slope of the blue line first. So I'm going to draw in the slope triangle for that blue line, which is a triangle, a right triangle connecting the 2 dots. This distance horizontally, we call that the change in x. And instead of writing change in, we just write delta. So the delta x here. Since we'll go from this point to that point, that means that our change in x is this direction to the right, which means it's positive. So delta x, or change in x, is positive 1. Our delta y from this point, this direction to this point, is the vertical change. So we're going up. So in this case, the change in y, or the delta y, is equal to 1, 2, 3. So our slope here, the slope m, is equal to delta y over delta x, is equal to 3 over 1, which equals 3. Now, usually, when a fraction is not equal to a whole number like it is here, when we have a slope, it's nice, I think, to have a fraction. But if it's equal to a whole number, we can write it as a whole number. Any questions on that first line's slope? All right, our second line, the 2 red points, we're going to use those to find the slope. So here we're going to go, we usually start with the point on the left and go to the point on the right. And because we're doing that, our delta y is going to be down. And whenever we go from the left to the right, our delta x will always be positive because it'll always be to the right. So our delta x there, we're starting here, was 1, 2, 3. So 3 units to the right. And our delta y, as we go from this point, down to that point, our delta y is down 1, 2, 3, 4, 5, 6. So our delta y equals negative 6. Because we're going down, our delta y will be negative. So again, our slope m will equal delta y over delta x always. So that's change in y over change in x is negative 6 over positive 3, which equals, well, negative 6 divided by a positive 3 is a negative 2. So there our our slope is negative 2. And I just thought, hey, I am realizing that you may not remember that m is our slope because we're thinking of the slope-intercept form of the equation. So our slope right here in that form of the equation is m, slope-intercept form of the equation. Questions on the red graph and its slope? Jojo, I don't know. Maybe M is the first letter of the Latin word for slope. I don't know. Would you look up Latin word for slope right now and let us know? But I'm going to continue on with the next problem, okay? All right, so the green line, we can actually go on top up here like this, and that's okay for drawing our slope triangle in. But we just need to remember that we start with the left and we move to the right usually. We can go the other direction. It's okay to do that as well. So here, our delta x is equal to, let's see, from right here, 1, 2, 3. Oh, our delta x is 3 in that one as well. We're moving to the right. Delta x is 3. And our delta y is up 1, 2. So our delta y is 2. My computer's a little laggy this morning. Fastigio. Hmm. All right. Well, then I don't know. Mr. Thomas, yes? Yeah. Hmm. I would recommend it, Thomas, because even if you think it's not going to help you, in this class, you can use your notes on tests. So, and in the future, you should use your notes to study for tests if you're ever able not to take notes. So I would recommend it, Thomas. And I want to remind you that in our modules, I'll pull them up right here, this note taking document right here, it'll almost always be the first file under synchronous. Thomas, do you have a printer? Okay. Well, for if you ever get ink, or for anyone who has a printer, this is a really great document to print out because what you'll see is, oh, and I didn't do it here. Why didn't I? Normally, and you can print it out this way. Print it out so that there are four pages per sheet, like this, so that you can take notes and you'd only have to print out two pieces of paper, one on the front, on the back, and then one more on the front. And these are the key slides for taking notes on. So this is a great way to take notes because it really condenses them and it gives you all the graphs and things that you'll need for taking notes in my class. Do you think that's pretty useful, Thomas? Are you talking about these class notes ones, the ones that are that I have my notes in? Yeah. All right. Great. Great. Well, I'm glad you're using those. Those are really useful. Thomas, thanks for asking. I'm going to get back to this problem, okay? Looking at the slope of the green line, delta y over delta x will be 2 over 3. Now, some people might be inclined, because they don't like fractions, to write this as a decimal, which would equal zero point 0.6 repeating. However, zero point 0.6 repeating is not as informative when it comes to the slope as 2 over 3 is, because 2 over 3 says go from this point up 2 to the right 3, and there will be another point. Up 2 to the right 3, and there will be another point. So the fraction really is useful when it comes to slopes. All right. Before I move on, does anyone does anyone have any feedback on Thomas's question um, regarding notes, or have any comments? How do you take notes? What works for you? Yes. Other questions or comments about how you take notes? Does anyone take notes on an iPad with an Apple Pencil? Because if I were you, I would import those slides that I showed you and then take notes on my iPad. I think it's the nicest way to take notes. One thing you can do, Jojo, is zoom way in while you're taking notes. So if you zoom way in like this, here, I'll show you what I mean. So the only reason I'm able to make my notes here look so good is because when I'm actually taking them, I zoom in like this and then I write it. And so it makes my notes look much better than they would if I were writing it like that. Yeah, it's just a trick. And Tran, I see you take notes on your Surface. Awesome. All right, I'm going to pause this video. All right, on this slide, this is just a reminder of the slope-intercept form of the equation. Our m here in the equation is our slope, which is delta y over delta x, and you've probably heard that as rise over run. Our b value is our intercept, and I should be a little more specific there. It is our y-intercept. It is the spot on the line that crosses the y-axis. And we can always see a y-intercept because the x value is always 0 on the y-intercept. Our x, that variable, is the input or the independent variable, and the y is the output or the dependent variable. Does anyone have questions about the slope-intercept form of the equation, of a linear equation? So anything in this form is a line. All right. So here we're going to look at equations, tables, and graphs and see how they match up, all right? So I want you to really be looking for these connections. I'm going to try to be as clear with them as I can, all right? And let me know if you have any questions along the way, all right? We'll start out with the blue equation there, y equals 3x minus 9. So in this equation, we can see that our slope is 3. And remember, it's sometimes useful to think about slopes in terms of fractions. And also, it's sometimes useful to think about slopes in terms of delta y over delta x. And the other thing we can see is that our y-intercept, and I'll just say y-int, is the point 0. And because this is a subtraction, it's 0, negative 9. All right? So in the table, we know that the point 0, negative 9 must show up. 0, negative 9. The other thing we can see is that because as our x value increases by 1, our y value increases by 3. So here what I'm going to show is as our x value increases by 1, our y value increases by 3. So that means that x will go from 0 to 1, and y will go from negative 9 to negative 6. And now we can continue that pattern where the x value increases by 1 and the y value increases by 3. And that pattern would continue in the table. Should we write this down? Do I have to copy the table down too? So Jojo, again, this is why it's really useful to print out those notes that I give you in advance, because you wouldn't have to write it down. So the note-taking document in Canvas, whatever works for you to make sense of your notes, okay? So depending on who you are and how you learn, take as many notes as you can and need. Does that make sense? Okay. Now in the graph, we can see our first point there, 0, -9. And I'm going to move that down or over to the side just a little bit. Whoops, and I forgot a parentheses there. And I want you to notice also then that we can see our slope, our delta x right there, delta x. We can see from our work on the equation that our delta x is 1. And there we see it, delta x is 1. And then in the graph, we can see that our delta y is 3, up 3. And we can see in our work on the equation over here that our delta y is 3. So notice that our delta y is 3 in all of these, and that our delta x is 1 in all of these. And so that's how we see the slope showing up in different ways, in the graph, in the table, and in the equation. I want to show you one other thing here in the equation. If I go from this point right here up to this point, remember the points that we really like on our lines are the points on the lines where the line crosses the corner of a grid. Here, 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 and so on. So if we're going to go up to this point right there, then I'm going to draw in that slope triangle for those 2 points. And notice that my delta x is 2 in this case, and my delta y is 6. And that works because delta y, 6, over delta x, 2, is equal to, so that's for this slope triangle right there, is equal to this slope triangle right here, delta y is 3 over delta x is 1. Both of those equal 3. So notice that it's okay if we use different points, and even if they're different distances away from each other, we get the same slope. If we ever don't get the same slope on a line, we messed up somewhere. Okay? All right, now I'm going to start with the graph. And on this one, I'm going to notice that my y-intercept here is the point 0, 5. So my y-intercept right here is 0, 5. So I can put that point into the table, 0, 5. And now, if I follow this line right there, there's a nice point on the grid. There's a point on the grid. There's a point on the grid. There's a point on the grid. So we can add all those into the table. So this one is the point 1, 3. This one is the point, let's do it down here, 2, 1. So I'll just add those. 1, 3, and 2, 1. And so if I look at the slope on the graph, I'm going to use the 2 points that were given. so that my delta y here is -6, because I'm going down 6, and my delta x is +3. So I'm going to put a blue around this because that's the slope of the blue one. And on the slope of the red one, we have a y is -6, our delta y, and our delta x is +3, and that equals -2. I'll put a red box around that one. So what we should see in the table is that as our x value increases by 1, our y value is decreasing by 2. And that is maintained. So our slope is -2, or -2/1. Jojo, you have a question or a comment? Mm-hmm. No, it can be different. Yeah. Um, some tables can be completely mixed up. Um, you mean if we're given a blank table? If we're given a blank table, usually it's best or easiest to just start with one point and then move to the right. The next point that we can see is intersecting the grid at the corner. That's usually the easiest way to do it. So if you're able to increase your x values by 1, you should, unless the problem asks you to do something different. Usually, yeah. Yeah. This next one, though, you'll see is not possible to make it +1. So here, I'm going to look at my graph. Well, oh, I didn't yet focus on the red one, and the equation. I can see in the equation that my slope is -2, which matches the slope I found here from the graph, and the slope I can see here in the table, which is -2/1. And my y-intercept, I can see by looking at the equation, is 0, 5, which matches my table and my graph, 0, 5. So all those things, it's important that they match or something is going wrong. All right, now I'm going to start with my equation, and I want you to tell me what the slope is. What is the slope of that equation? Anybody? It's a fraction. 2/3, which, remember, delta y is 2, delta x is 3. And the y-intercept here is a little tricky. There's no b value here. No b value. Well, it's there, it's just not written there. Really, it's like +0. So our y-intercept always has an x value of 0, and here the y value of our y-intercept is 0. Okay? So in our table, we can write 0, 0, and then we can use our slope. Our slope of 2/3, that's a change in y of, so a change in y of 2, and a change in x of 3. And then if we continue that, a change in x of 3 will take us to 6, and a change in y of 2 will take us to 4. And so if we look on our graph, we see that we have this point right here, 0, 0, which matches what we found in our equation and what we put in our table. And then we have this point right here, which is the point 3, 2, which matches our table. And if we continue looking to the right, right here is going to be our next point, which would be 6, 4, which is also in the table. And I'm going to draw my slope triangle in right here to keep it out of the way of the other information there. My delta x is 3, and I'm going to put a little arrow there like that to say my delta y is 2. And that's a lot of information on one slide. Lots of stuff. I hope that it all makes sense. Does anyone have a question before we move on? Or a comment? For how many people is this review? Okay, all right. And did you see anything new or different in this time around, Mia? Okay, good. Yay. Anyone else? Yeah, all right. That's fair. Same for Naomi. All right, all right. Well, here we go on. Now we're going to put all of this together, and I'm going to talk about, though, this new thing, the slope formula. And you may have done this last year as well. And if you did, that's great. We're going to go over it again, and hopefully you'll understand it even better. So when you're given 2 points, so this blue one and this red one, it wants you to find an equation. Notice that this point right here has an x value of 0. That means that that point is our y-intercept. All right? That's going to be important later. First, we're going to find the slope. And what we're going to do is we are going to identify one of these points as our first point and one of them as our second point. And the way that we're going to mark that is by saying, hey, this is going to be x1, y1, the blue point there, and the red point is going to be x2, y2. So this is my first point, and this is my second point. So 0 is my x1, 1 is my x2. That means it's the x value of the first point and the x value of the second point. All right, and then 4 is my y1 and 6 is my y2. The y values of our first and second points. And the reason why we're going to identify them that way is so that we can take our y1 and subtract from that the y2 in the numerator, and take our x1 and subtract from that our x2 in the denominator. So our y1 is 4. Oh, let's see, we're going to calculate the slope here. That's what we're doing, slope. So our y1 is 4. And we're going to subtract from that our y2, which is 6. That's in the numerator. In the denominator, we're going to take our x1, 0, and subtract from that our x2, 1. So when we do that, I want to change the colors on these because those are not related to the first point. They're just part of the equation. Sorry about that. 4 minus 6 is negative 2. 0 minus 1 is negative 1. Negative 2 divided by negative 1 is positive 2. Now, lots of people will ask, what if I made this my second point and this my first point? So I switched them around. And I'm going to go through that. I'm not going to keep it up here, so I'm going to call this x2 and y2, x1 and y1. So my y1 would be 6, minus my y2 would be 4, over my x1 would be 1, minus my x2 would be 0. 6 minus 4 is 2. 1 minus 0 is 1. Look, it came out to be the same. The difference is here, they were both negative, and here, they're both positive. So you should always get the same slope no matter which point you choose as your first or second point. Okay? But what you can't do is have this one be blue and then switch these around like 1 minus 0. That would get everything messed up. Okay? So we found that our slope is 2, and I'm going to say, all right, well, that's going to be yellow. And so our equation, remember, is y equals mx plus b. So our m there is our slope, and our b value, our b value is the y-intercept. So I'm going to take the green one here and say, hey, here is the y value of our y-intercept. Okay? So our equation then is going to be y is equal to m, well, m is 2, x, that's just our other variable, y and x, and then plus b. And since b is a positive 4, it will be plus 4. So there's the equation. Now, I know lots of people, when they see this slope formula, they don't like it. They feel anxious about it. So I'm going to give you another process to use for now. I want you to use that slope formula later for sure. But for now, I'm going to give you another process to use. And so we can write our 2 points in the table, 0, 4, and 1, 6. And then we can look at our delta x. Delta x equals 1. Delta y equals 2. So our slope is delta y over delta x equals 2 over 1, which equals 2. So you'll notice that whether we use the slope formula to calculate our slope or the table to calculate our slope, we get a slope of 2, which is what goes right here in the equation. All right, so you can use either method for now. Later, I will ask you to use the slope formula sometimes. All right. But if I don't give you a table, you can always make one with 2 points in it. And the reason why we only need 2 points is because if we know that a thing is a line, then 2 points determine the slope. All right? Questions on this? I'm going to go over 2 more examples like this. All right. So here's one of our points. Here's the other point. And so this time, let's make our blue one our second point. So x2, y2, we saw that it doesn't matter which is which. That'll make this x1, y1. So let's see, our x1 and y1 and our x2 and y2. All right. So we're going to do y1 is negative 6 over, over y, or excuse me, I'm getting everything all confused here. Y1 minus our y2, and because it's a negative 2, our y2 is a negative 2, I'm going to put that in parentheses because it would just look weird to do minus minus. It gets a little confusing. Our x1 is 4 minus x2 is 0. So this will equal negative 6 minus 2 is the same as negative 6 plus 2, which is negative 4, over 4 minus 0 is 4, which equals negative 1. So our slope is negative 1. Now if we do this in the table, I'll put it in the order that I have here. 4, negative 6, and 0, negative 2. And it's okay that our x value here is bigger than our x value here. It doesn't make any difference. Now, there is a standard way to do it, but we don't need to worry about it so much right now. Notice that our x value decreases by 4, and so that's our delta x is 4, and our delta y is positive 4. So that means that our slope is delta y over delta x, which equals our delta y is 4, our delta x is negative 4, which is negative 1. Now notice that up here our delta y was negative 4, and here our delta y was positive 4. Here our delta x was positive 4, here our delta x was negative 4. But in both cases, our slope is negative 1. That happens depending on how you calculate, and it's perfectly okay. So our equation, y is equal to m is our slope of negative 1, x plus b. And our b value is the y value when x is 0. And we can see it in our point up here and in our table right here. And so that is going to be minus 2 because the y value is negative 2. Questions? Here's our last example of this kind. And actually, we've been going for quite a while. I'm going to pause the recording. All right, so the last example of this kind I think the color coding helps here. If you don't, then you don't need to, but you can do color coding like this if you want to, if you're able, and you might find it helpful too. All right, so x1 and y1 are going to be blue, x2 and y2 are red. So here our slope is equal to y1 is 15 minus y2 is 3 over x1 is 3 minus x2 is 0. So that's going to equal 15 minus 3 is 12 over 3 minus 0 is 3, which is 4. In the table, I'm going to put our 0, 3 first. It's just kind of standard to put the y-intercept first if you have it. And 315. So our delta x is equal to 3. And our delta y is equal to 12. So the slope, delta y over delta x, is equal to 12 over 3, which equals 4. For the equation, y is equal to 4x, and then our y-intercept is the y value when x is 0. Since it's a positive 3, this will be plus 3. Questions? Jojo, if your connection is bad and you're having a hard time seeing or hearing, if you turn off your video, although I love to see you in your field of flowers, it might help if you're still having troubles. Oh, okay. All right, are there questions on this one? All right. So I'm going to draw the graph of a line given 2 points. So I have 2 points here. The first point is 0, 0. My x value is 0, my y value is 0. The second point is 1, 4. My x value is 1, my y value is 4. Now I can draw a line. What I notice is that as I go to the right one, I go up 4. So I can draw in that little slope triangle. Delta x equals 1, delta y equals 4. And then I can reverse it and say, all right, well, I can have delta x equal negative 1 and delta y equal negative 4. And then I will get another point right there that was not given. But that allows me then to connect my points maybe with a little more of a straight line. And it's a little curvy. I see that. That's okay. Doesn't have to be perfect. Any questions on that? Good. This part I hope you find to be pretty straightforward. We have the point 1, 8 and the point 4, negative 2. 1, 8. Whoops. That's going to go, let's see. There's one more. There's one more. 1, 8 will be right there. Whoops, that's no good. And 4, -2 will be right there. Now, something you might notice is that we're moving to the right 3 and we're moving down 10. That doesn't come out to be super nice. So we're just going to connect those as best we can, like that. Questions on that one? All right. Here, whoa, last one here. So our first point there is -3, -2, -3, -2, and 4, 5. I'm going to draw that slope triangle in there. See that my delta x is to the right 1, 2, 3, 4, 5, 6, 7. My delta x is 7. And my delta y is 1, 2, 3, 4, 5, 6, 7. Oh, my delta y is 7. So my slope is 7 over 7, which is 1, which means as I go to the right 1, I go up 1. So I'm going to be hitting the corners of all of those grid marks. So by putting in that slope triangle, it helps to make my line a little better than it might otherwise. Questions on that one? All right. I think that's the end of our recording for today. So you can go and find this recording on the Canvas page.